Alright, good morning, everybody. Uh, so, I kind of predicted this to be a weird topic. I actually had a student make me aware that there was a little bit of confusion, and you guys were coming up with answers that were, well, you guys would come up with an answer that everybody was getting, and my answer key was a little off. It happens. I just went through it in 5 minutes. I didn't even do any work, which is probably a bad thing, but a good thing that you guys caught it. So I'm going to kind of go through some things and highlight. I don't know why I erased that. Actually, I do know why. Because today is the second day of March. Okay. I can say today because I'm actually shooting this video while Bub is watching Max and Ruby. So he just laughed too. So let's go in through some of these examples that I gave you, and I'll do a few more. I'm not for sure what the confusion is about, but hopefully this will take care of that. So let's go ahead and look at that example 1 again and why it is what it is. Alright. All I'm doing, and I guess everything in orange here, okay, underneath this yellow streak, that's a rule, okay? It's in my terms, but it's a rule nonetheless. If you plug in this negative x, and for every x into the function, the original function here, okay, and when you plug that negative x in and you end up with the exact same function as the original, that's when you know you have an even function. Okay? Negative 3x squared plus 4. That's the same as what I came up with down here. Now the rule kind of looks like this. I'm going to go to a side note here, which I know you guys love that, right? Right here in the box. Here's the rule. Oops. If you have f of x, the original function, and that equals f of negative x, okay, that means that you have an even function, okay? Now, when I go to example 2, alright, I'm going to do the same thing, but everything is the exact opposite. And what I mean by that, I'm going to see if I can actually go backwards. Oh, sweet. I love technology sometimes. Not all the time does it work great. So, what I did here, okay, is when you plug that negative 1x, that's how you determine whether it's even, odd, or neither. So when I plug in this negative x, I'm going to go forward now again, and I use parentheses and close it, okay? Now right now that's negative 1x to the third. Well guys, that's going to equal negative x to the third power minus 4 times the negative 1x again. Now what's going to happen is, if you pay attention to the signs in front of each term in the function, that 2x to the third, it's going to change to negative 2x to the third. Well, that's the exact opposite. Think about opposite. Opposite of 4 is negative 4. Opposite of negative 18 is positive 18. So that's what I mean by exact opposite. And I'm going to go ahead and just, like I did the other day, just distribute that out. Well, there's that positive 4x. Well, in the red original function, the 2x to the third minus 4x, well, that minus 4x already changed to the exact opposite, positive 4x. So, when I say opposite, it's just opposite sign. So, and I highlighted that from yesterday. So, exact opposite means that it's an odd function. Okay? And what that basically is saying, if you want to write it as a rule, okay, an odd function is said to be odd if you started with, I did the same thing again, if f of x, okay, when you plug it in and the negative isn't out in front, okay, meaning I'm just going to change the sign in front of each term when you plug in the negative x. And it actually, yeah, I'll stop right there. And the rules in the box, that's a textbook thing. Okay, that's that's not Mr. Seidel's dumbed down version. Mr. Teeters, he's an adjunct professor down at Shawnee, as you all know, and everybody's got their style. Now, I'm sure he's seen, just like me, all the different ways of doing these types of problems. I'm trying to show you the easiest way that I know, and he might know an easier way than I do. So, trust me, he's a brilliant guy. Giving you a shout out, Mr. Teeters. I'm not trying to suck up and just for another jam session, a number 2 jam session. I already got the number 1. I'm looking for a second jam session. Guys, he's absolutely amazing on guitar. Probably one of my, if I had to pick local heroes, he's at the very top of that list. All right, I'm gonna cry. Let me go through this example. Now, this was a neither function. It's neither even or odd. What happens is, to me, and I understand that if you run into something that's neither, the best way I could put it is some of it changes, some of it doesn't. Okay, some of it's the exact opposite, some of it's not the exact opposite. That means it's the same. I just pulled a Scott Sheltman. So, I had trouble with this part myself in high school, because I wouldn't work throughout the whole thing. I just assumed that everything, if one thing changed or one thing stayed the same, everything was going to stay the same, or everything was going to change. That's not the case. So it's good to show the work. Now, here's a hint. Sometimes you could get away with it. Right now I'm plugging in negative 1x, just like I did in the example. If you look at that last term, that number, positive 4, there is no variable x to plug in at the end of that. Okay? And I'm actually going to intervene on this. I'm not going to just hit the redo button. this and this stayed the same. Okay? So, right now, just by looking at that part on the end, I'm thinking, that might be an even function. If you look at the first term, excuse me, this first term here, you might just have to, just work that first term out. And when I distribute, I get negative 2x to the third. Bub's hitting me right now. That's why my handwriting is sloppy. So the sign in front of the 2, it changed. It went from positive to negative. Well, if this stayed the same and this changed, it seems like to me it don't know what it wants to do. Now, if you're indecisive, this function's indecisive. It don't know if it's positive or not positive. Oh my gosh. It don't know if it's even or odd. Well, the best thing to say is it's neither. It's not doing anything. It's like, which way do I go? Which way do I go? Sorry, Bub. Which way do I go? So, that's the best way of looking at it. If you can't decide if some things change and some things don't, if it's got a mind of its own, it's a neither function. Okay? Now, graphically, I don't know if this is an issue, but, I just look at the even functions as being a perfect reflection along the y-axis. It's a mirrored image. Okay? It's a mirrored image. Now, if it's not a mirrored image, I'm already thinking, okay, if it don't look like it's cut in perfect half, it's symmetric in this section here, okay, well, it's got to be odd or neither. Now, the neither ones are kind of easy to figure out because they just, when you look right down the y-axis and you see that it's not a perfect reflection, and it don't look like any kind of rotation about the origin. It's not even intersecting through the origin. It's a neither function. I'm not for sure if that is any kind of problem with you guys. I'm just guessing. I know one particular student asked me if I could FaceTime the class. Guys, today I won't be able to do that, but I will eventually. I'm going to try to next week. FaceTime, and that way I can kind of see how everybody's doing and answer any questions that you're having. We'll see how this goes. Mr. Teeters and I, we talk and, converse back and forth about, progress. Hey, ask him. Let him know what's going on, what we're having trouble with. That way I can get with him and, we can figure this stuff out. The quiz is very, very important, very similar to what we're doing. This is on the pre-post test, and I think it's a select all that apply. So make sure you go through it and ask questions. Okay. You got the man, the myth, the legend right there. He's a really good guy. So if you have any questions, just ask him, and then he can relay it to me, and we can talk about, what's in store for next week. All right? Well, guys, it's about 15 minutes. I'm going to call it a morning. So I will maybe chat with you soon. Later.